everybody. I'm Nicola. If I haven't said hello to you, I will find you at some point during the day and say hello, or just come and find me because I'm too busy chatting to everyone. But Mike, who is our vice chair, if you didn't know, he is also the brilliant organizer of this event, and we need to get him some more help next year because there's so many people here today. But Mike is actually going to give us a talk now, and we're going to look at some of the history of quality in software. Is that right? Okay. And he's going to talk about Friday, 16th of May, 1924, a new beginning of quality.
Thank you very much. Yes, we have a theme for today's conference, which is the past, present and future of testing. Sam was talking about law and how our legal position is based on common law, which is the Middle Ages. I'm going to move us forward to 1924, the 16th of May 1924, 100 years and 1 month ago, because we have an important centenary. And we don't get very many centenaries, so I thought I would hang my talk on the fact that we have this centenary. I'd also like to thank the SIGIS committee for all their work of putting on today's event. And I'm going to speak to you about the impact of a memo sent by Walter Schuhart on the 16th of May 1924. We'll speak for about 20 minutes and then I will take questions. Before I talk, I'm going to say a couple of words about myself, as well as the work I do for SIGIS, as I'm a volunteer for SIGIS. I'm the solo tester at Geckoboard, and at Geckoboard we try to ensure that every person in every organisation has access to understandable data so that they can make good decisions. And we do this by enabling them to make and share dashboards such as the one on this slide. I'm going to speak to you about control charts. On the slide here, there's a mock-up of a control chart. They started with Walter Schuhart's memo in Bell Telephones in 1924. They are a tool for improving quality. They're widely used today. For example, if like me, you've got a Fitbit, the health data on your Fitbit is actually based on a control chart. Control charts can also be called process behavior charts. And I'm going to use that term today because it's more modern. Now, in the early 1920s, Bell Telephones were building the first national telephone system for the United States. This was a massive project. European countries had their own national telephone systems, but it was much, much smaller than that. And the telephones were made at the Hawthorne Works in Chicago. Bell Telephones wanted every telephone to be the same. And they advertised that nothing was alike as two telephones, but the public felt differently and weren't happy with the quality of the telephones. Walter Schuhart was focused on improving the quality of the telephones. And to that end, he sent a memo to his manager on the 16th of May 1924, which included a drawing of a process behavior chart. There was no fanfare, there were no fireworks, there was no parade, but there should have been. Because from this point forward, the cause of failures can be seen as a result of the system or the process, rather than of the individual. This should have been the beginning of the end of blame. But it was the beginning of the quality movement. And his charts were tested on 1,000 production lines a day. But where did his thinking come from to create these charts? Well, he wrote in the 1930s, in this book here, that at the time of Aristotle, quality was indicated the goodness of an object. But really, that's not adequate for us. How do we judge what the goodness is? But quality in Latin actually is qualitas, which means how constituted. And if you look at how things are constituted, you can get an idea of quality. For instance, if you're looking at water, water is the combination of oxygen and hydrogen. So you need to understand oxygen and hydrogen to understand water. And so that's something we're describing as, can be described as a group of conceptions. And the minimum number of conceptions to describe it can be called its qualities. And Schuhart said the same was true of manufactured objects. A manufactured object has qualities, not a quality. And so he was interested in things like weight and density as the qualities of a manufactured object. In software development, we too are interested in the qualities rather than the quality of an object. The idea that a product has qualities rather than quality actually has led to the idea of what we would talk about now as quality attributes. So these are the quality attributes that Walter Schuhart was talking about. That's the language we would use today. And in software, we would talk about quality attributes like usability or performance. And quality attributes that are measurable and objective can be analysed on process behaviour charts. For example, performance test results. Because you can look and see how you've improved and what an improvement would mean. Now, if I was to look at inflation, inflation is like a quality of the economy. It's a quality attribute of the economy. It's objective, it's measurable. And I'm using inflation for this chart because it's not commercially sensitive data. And this chart shows UK inflation as it spiked post-COVID. You know, inflation spiked worldwide post-COVID. But if you look at it, it's a line chart, actually. There's not very much data on here. It's a line chart. It goes up and it comes down. That's what line charts do. When I look at a line chart, I'm certainly thinking, where's the average? Has it got better? Has it got worse? Is the end higher than the beginning? What does that mean? It doesn't help you at all, really, a line chart. This is hard work. But the same data can be displayed on a process behaviour chart. A process behaviour chart helps us understand the data. And it does this because it contains 3 additional lines. Now, if you look at here, you've got the time series data of inflation. You've also got the average. I've taken the mean. So you can see the time series data against the average. You know when it's above average, when it's below average, you can see what trends are. But there are also upper and lower limits that have been calculated. These are upper limit here and a lower limit here. These are calculated from the average. So they're not targets, they're not goals, they're not imposed. They're referred to as the voice of the data. This is the data itself telling you what its natural upper and lower limits are. This helps us because we can see the data against the average. It helps us also because we can see the data against these upper and lower limits. Points that go outside, faults are outside these limits, are said to have a special cause. They're a fleeting event, a one-off event. Like COVID, hopefully, was a one-off event. Errors happen with inside the limits are said to have common cause. These are faults within the system, within your system. When Shewhart made his first drawing, he put an arrow to some points above the upper limit and says, this indicates a problem. Yeah, and this was a problem here, wasn't it? You know, this inflation, it was really painful. But this chart shows you really clearly where the problem was and the nature of the problem, and it shows you that it was a special event. Knowing whether or not an event is a special cause or a common cause helps us know how to deal with it. And we can see at this point that actually inflation had a special cause because it's above the upper limit. But we can use a process behaviour chart to take this to another level of analysis. This is an XMR chart. The top chart is the process behaviour chart we've just seen, referred to as an X chart because X bar is a symbol for average, and this has got the average on it here. Underneath, we have the MR chart, moving ranges. And you can see the moving ranges here. The moving ranges are the difference between the points on the time series data. And on the moving ranges chart, I've calculated an average and I've created an upper limit. The moving ranges are useful because you can see here where there are big changes in the time series data. And you can see that there are 2 big changes here that are so big, they jump outside the upper limit. So actually the moving ranges chart is telling you this is an event you want to investigate, and this is another event where you want to investigate. This is where your time series data changed. Yeah, the other thing I'll say is about the maths on here as well. The first time I saw one of these charts, I thought health. But actually the maths isn't difficult. You're given the time series data, so you've got that. The moving ranges, well, actually, I created this chart using TypeScript, and there's an ABS function or ABS function which gives you the absolute difference between 2 numbers. So that's how I calculated that. If you use Google Sheets or Excel, that's also got an ABS or ABS function, so you can use that to create this curve as well. Well, these are averages, these are means. So whichever programming language or spreadsheet package you're using has got a function that will enable you to calculate that. And the upper and lower limits are simply factors applied to the average. So in fact, they're very easy to calculate as well. So though the chart looks complicated because it's got lots of lines on it, it's not really. So actually, what if the chart wasn't for inflation? You know, performance is a measurable and objective qualitative attribute of our product. For example, page load time. What if the data in the chart wasn't inflation, but was actually your page load time? How would the chart help us understand that? Well, we can look at the top chart, we can see immediately that we had special causes. We had special events that caused our performance to increase in time. We can look at the moving ranges charts and we can see when it increased. We know there was an event here that we need to investigate. We can also see there's another event here when it fell. We probably want to investigate that. Then what else will we do? We can also sit there and say, what is the story here? Because these sorts of charts are very good for telling a story. You can sit there and say, well, let's create one chart up to this event here. That would have its own average, its own upper and lower limits. You can create another chart between these two events when all the bad stuff is happening. And you can create another chart after if bad stuff has finished happening. And you'd have three charts. You'd be able to see, was the average better or worse afterwards? How did it change during these big events? You could see what the story is. How was your process different to what it was before the big events occurred? Process behavior charts are not just signal and noise. Signal when there's an event outside control limits, and noise when there's events within the control limits. This approach gives you filters, and the control limits allow you to see which points fall outside the control limits, and also analyze non-random patterns of variations with control limits around the average. And there are 8 rules for understanding those. The first 4, I believe, came from Bell Telephones in the 1950s, and the second 4 came from Lloyd Nelson in the 1980s. First point, it was 1 point is more than 3 standard deviations from the mean. Second point, if there are 9 or more points in a row on the same side of them. Third rule, if there are 6 or more points in a row are continually increasing or decreasing. Fourth point, 14 or more points in a row alternating direction, increasing or decreasing. Well, one of the people who helped me understand these charts is Dennis Sargent, who used to be a senior manager at Bell Telephones. And he said when he was a manager at Bell Telephones, he had some data sent in, which is 14 points like that. Well, these rules tell him that's wrong. That data cannot be like that. And he went back to the person who sent him the data and said, what happened? He said, well, I've been filling that form for 30 years. He said, I always make the numbers up. You're just the first person to notice. And actually, it was these rules which enabled him to notice. It's just a case of how they're useful. Rule 5, 2 or 3 out of 3 points in a row are more than 2 standard deviations from the mean. Rule 6, 4 out of 5 points in a row are more than 1 standard deviation. Rule 7, 15 points in a row are all within 1 standard deviation, and 8 points in a row exist, but none within 1 standard deviation of the mean. So these rules can be used for analysing your data around an average, and will tell you if you've got a problem. So here's a process behaviour chart of some fake performance data. If you look at it, the time series data is all within the control limits. So which means that the performance is under statistical control. It's mathematically predictable, because if in this length of time it's stayed within those limits, it's reasonable to presume it will stay within those limits unless something special happens. It means that that process is stable. It doesn't break any of the Nelson rules. This is your system. Are you happy with it? So if you're not happy with it, you need to work on the system itself, not deal with a one-off problem. And if you work on the system, well, actually, have you got other charts, other performance measures, which perhaps are not under statistical control? Those maybe are things that you want to look at instead of this one. And you may want to spend more time on them. The other question is, if you want to improve your performance, what do you want to improve? Do you want to have less variation, or do you want to improve the average? And if you are working on the system directly, you've really got to be aware of tampering, because you could make it worse. It's not the same as dealing with a special cause. Now, Schuhart didn't only create these charts, but he also created a cycle. In 1939, he was working and he had 3 points in a line, and he changed those to 4 points in a cycle. He saw that teams who worked in that cycle produced better quality work, and it was called the Schuhart cycle. And his friend, colleague, and mentee, W. Edwards Deming, probably referred to as the greatest management scientist of the 20th century, spoke in Japan in the 1950s. He used this cycle and he introduced it as the Schuhart cycle, but it came to be known as the Deming cycle because he had introduced it. And there's 4 parts to the cycle. Plan, do, study, act. So if you're looking at your charts here and you've got an issue you're not happy with in the charts, you can plan an initiative to deal with that issue. You can then do the initiative. You can then study the results of the initiative, and then you can act on the results of the study. Process behaviour charts plus the Deming cycle are a process of continual improvement. But what metrics can you use process behaviour charts for? Well, I've talked about performance metrics. That's something I've used them for. Another way that I've used them is actually a few years ago, I was a global test lead, and I had 2 development teams I was working in different countries. One was really motoring. It was making frequent releases, had very few incidents. And the other one was struggling with monthly releases and heroic programmers who were having to fix the bugs. And I wanted to understand what was going on. And what I did is I tried to look for something that should be a constant process in each team, which would actually be the writing of unit tests. You should write roughly the same number of unit tests every iteration, every week. And I found the team, as I created process behaviour charts, the number of unit tests created each week by each team. And I found the team that was really motoring produced a chart which stayed within its control limits, that was under statistical control. And the team that was having problems, well, some weeks they produced some unit tests, some weeks they didn't write any at all. And some weeks actually there were less, they deleted some. So this chart was incredibly useful and enabled me to have a conversation with the next layer of management up and say, look, there's something wrong with this team. They're not following good engineering practice. Other things you could do is look at the frequency of deployment. Somebody else who helped me with understanding these charts is John Willis. And when he was a senior director at Red Hat, he used to get a process behavior chart for each of his development team showing their number of deployments. And if the number of deployments went outside the control limits, he could see that they had an issue that they needed help with. You could also look at the number of frequency of incidents that occur and see how often these are occurring and what patterns there are with that, and that there are other issues you could look at too. But I also like to contrast process behavior charts with traditional metrics, because metrics without process behavior charts can be like driving while looking in the rear view mirror. If you look at your metrics and you compare what you're doing today to last month or last year and use that as a way of predicting what's going to happen in the future, you may find that last month or last year aren't good things to compare with in the future. We've had COVID recently. We had Russia's invasion of Ukraine. All of these things affected the world economy, and they will quite possibly affect some of the metrics that you were looking at. And other events can as well. So, but actually process behavior charts aren't going to be affected that way, because you're actually looking at the process. You're listening to the voice of your process rather than actually looking at individual data points. Process behavior charts are a powerful tool for managers. For the first time, they give managers a tool to compare variation across workers and machines. Before these charts, the way that quality would be enforced, there'd be an inspector at the end of the production line, and he'd check the quality of goods coming off. And if I was on a telephone production line and my production line produced some bad quality telephones, he'd come up to me and say, Harris, don't do that again. That was the process. Now, when you've got charts, you can actually look and see that the cause of the problem is the process, it's the system, it's not the individual. And in that way, it should have meant the end of blame. And it should have been, or it has been used as a tool to drive out fear from the system and create what we would now call psychological safety, because you're actually looking at the causes of problems being the system rather than actually being the individual. And so this actually enables managers to fix causes of errors. And new charts so they move within the tolerance limits, and that way they become a way to continually improve quality. They're also a way of managing uncertainty because you're listening to the process. You understand what your process is. Now, today, process behaviour charts are very widely used. I mentioned Deming was Shewhart's mentee. He took them and used them in the US Census. They were also used by the American manufacturing during World War II to produce war material and make sure that it was of very good quality. At that time, Stanford University was running courses on how to create these charts. And I think Deming spoke about them when he went to Japan, and they became very influential from that point. But you can also use them to test for load testing. That would be appropriate. You can use them to analyze customer service data, because actually, are there peaks in your calls to customer service? If you look online, you will find the English National Health Service produced lots of documentation on these charts. And I was at a meeting down there a couple of months ago talking to a local director of the NHS, and she told me that these sorts of charts are used for predicting health outcomes, measuring health outcomes. They're widely used in nuclear power stations. They're used in car manufacturing now. Obviously, there were Deming speaking in Japan. He had an influence on Toyota, and through the influence of the Toyota production system, they've become very important. They can also be used in education. Someone else I've been speaking to is John Hughes, who's the Chief Learning Officer of the United Schools Network in Ohio. And he says that his school networks use these charts to understand educational issues. They can be used for looking at inventory control as well. So you could look at them, how you measure your inventory in supermarkets. A paper I found said that you can look at judge the maturity of a supermarket system in a country by whether or not they use these charts. I think our supermarket system is probably mature. So I think it's reasonable to assume that our supermarket system uses these charts. You can also look at ways of measuring marketing campaigns to see whether or not you're getting the responses that you want and what patterns there are. I found that Coventry University runs a day course on this sort of charts, which I presume is all the car manufacturing in Coventry. What I'd like to do is encourage you all to make your own process behaviour chart. And these are resources that you can use to do those. The American Society for Quality has a spreadsheet template that you can use. That's there as available. This book is incredibly useful. It tells lots of stories about business and about the economy using process behaviour charts, and it contains all the maths that you need in really short. So I think it's a really very useful book. It's helped me an awful lot. And there's a great video here from Dennis Sargent talking through process behaviour charts, and that's has the story about the 14 points in it. So if you want to take your charts, I would encourage you to use these resources. And Dennis has this nice quote. He says, "Start where it's meaningful for you. You don't have to go and start with some big plan. Start somewhere small. Create some metric that you're interested, that tells you something about your process, your business, and create a chart for that." And to conclude, there's really three things I wanted to say. One is that Walter Shewhart's memo from 100 years and 1 month ago has had a huge impact. We probably all now use services and products that use those sorts of charts. Second thing is actually that you're unlikely to find a quality technique that's been better trialed, that's better tested. I don't know other techniques that are older, but it's incredibly widely used, and it's been used for a very long time. So we know it's what works and it's not on trial. And lastly, is I'd like to say that I hope that this talk encourages you to create your own charts and gain insights from doing so. And I'd like to say thank you very much for listening to me. And if you've got any questions, I'd be very pleased to answer.
You mentioned you use TypeScript to create the graphs.
Yeah.
So I wonder, for someone like who's starting,
Yeah.
learning how to create graphs, would you recommend any language, or the language it doesn't really matter?
For me, I test Geckoboard, and we have a datasets API, and I use TypeScript to create a Node app, create these charts, and that worked for me. It was another way of you're using TypeScript for doing something other than test automation. So I grew my knowledge of TypeScript. But the easiest way to do it is to get the spreadsheet template from the American Society for Quality. And if you want to do a bit more yourself, you could create your own spreadsheet template, because as I say, that the functions are all in there. You create averages to create your adds and absolute functions, and the equation with the from this book, which shows you the factors that you need to use. So there are a number of ways that you can find which way works for you.
Yeah, I was just wondering, is there like a typical like minimum or like even maximum amount of data points where you actually get information? Do you find like?
Thank you for the question. People talk about needing something around 20 data points to really have confidence in your data. But that shouldn't really stop you from starting. When I started the charts for the unit tests, I could see a pattern after 4 or 5 data points that actually one of the teams had problems writing unit tests. So I would say start where you are, but actually think about how much data you've got. The more data points you have, the more confidence you'll have. And the general guide is something around 20. Lewis, yeah.
How often in performance testing have you seen a spike and investigated it and have no idea why there's a spike?
It happens. That's when I go and talk to the development team, and you've got tools for going in and seeing what happened and trying to learn from it. But that's the time when you want to work collaboratively, isn't it? So, yeah. Thank you.
We have an inflation example, it's something that you can compare over time. So your upper lower limits and your average will be horizontal. But if you were to do, say, GDP, where you'd expect growth over time, could your average macro and lower limits be on an incline, or would you adjust your data so that it falls into that horizontal?
So that's up to you, actually. It's about the story that you want to tell. It's a good question, because you may sit there and say, I want to look at GDP in this period, and therefore you would have your average and upper and lower limits for that period. Or you may sit there and say, well, actually, I want to look at more than one period, and say, I have seen charts done where you would have data coming in on one set of limits, and then for 1 year, and then another set of limits for another year. The example that's often used is if you looked at a quality improvement program, you might have before, during, after, with 3 different sets of bands, and hopefully, you know, after you can see you've improved. They talk about that. The phrase they use is the frame that you're viewing on, and that's just choosing which frame that you want to have, the story you want to tell.
But you will keep those 3 lines horizontal for this.
Well, something to be horizontal, and then there might be another 3 set horizontal. That's the point, that they are horizontal rather than moving, because that way you can see how the time series moves against them.
You have used these charts for anything else than performance tests?
For me, I use them when I was looking at unit tests. I have spoken to our marketing department, so they like to look at, say, the impact of a sales campaign. I could do that as well. And I think that there are more uses as a manager than there are as a tester, but there are uses as a tester. And I thought it was useful to have coming here, because actually we shouldn't only want to be, we should have ambition to want to move up the food chain, so to speak. And actually these are the opportunities there where you can see a repeatable process, like unit testing, like deployments. Those are things that you can just have. Are there any other questions? I'd like to say thank you very much.